Welcome to the Department of Healthcare Access and Information's NPC5 Water Rationing Plan webinar, brought to you by the Seismic Compliance Unit here at HCI. This webinar will include an overview of the code requirements for NPC5 Water Rationing Plan to support 72 hours of emergency operations. Today we will cover the updated HCI Advisory Guide A5 released this month, the CDPH checklist, a discussion of water, which includes potable and industrial water and wastewater requirements, insights from ongoing evaluations, and frequently asked questions. If you haven't done so already, feel free to download a PDF copy of this presentation available to you in the Go-To panel under the Handouts section. We're scheduled to be here for 2 hours this morning. We have a lot of content to cover, but we will try to do a question and answer session at the end of the presentation if time permits. If you have a question during the presentation, please type your question into the questions section of the Go-To panel, and we will try to answer them at the end of the presentation. Please be sure to keep your questions generic, but if you have a specific question about a specific project, please feel free to email your questions to seismiccomplianceunit@hci.ca.gov. That's seismiccomplianceunit@hcai.ca.gov. If the presentation experiences transmission difficulties, please log out and log back in using the same login information sent to you by GoTo when you registered for the presentation. And we will do the same if we are experiencing transmission difficulties on our side. AIA credit. In coordination with AIA California, you will be able to earn 2 AIA continuing education units by attending the entire presentation today. If you have questions regarding continuing education units, please contact AIA California. You should note that multiple staff members from one office should register individually to receive separate logins for individual certificates. A certificate of completion will be emailed from GoToWebinar to registered attendees who logged in and attended the entire presentation. Note that certificates will not be available from HCI. So for today's presenters, we have with us Ollie Sumer, Supervisor of Seismic Compliance Unit here at HCI Office of Statewide Hospital Planning and Development, and Kamal Khalsi, Senior Structural Engineer, Seismic Compliance Unit here at HCI Office of Statewide Hospital Planning and Development. So once again, thank you for joining us today, and without further ado, I hand the presentation over to you, Ollie.
Thanks, Kelly. Let me bring back the title slide. So, good morning. We are very excited to bring this webinar. There are a lot of questions that we are getting. There are deadlines coming up, which we will talk about. So, we're gonna today focus on NPC5. And when we send out this meeting invite or the webinar, close to 700 people signed up. So there's definitely a good interest in the topic. So today we will not only talk about what NPC5 is, but also we will go into the revised guide that we published yesterday. So if you haven't seen, please go and check the revised A5 guide on our website. And following that, we will talk about some examples, frequently asked questions. So if you attended at the webinar before that we gave a couple months ago, this webinar go much deeper into the NPC5 topics. Before I move forward, I'd like to thank Patrick Rogers, Kamal, for really putting this presentation together. So, you know, these are the Seismic Compliance Unit engineers who will be reviewing the NPC5 reports. So with that, I'll move forward. Let's start with hazards. So I'll give some background information on MPC5, and then we'll move to Kamal's explanation on A5 guide. And towards the end, if time allows, we will have some question answer period. So why are we doing MPC5? California is a seismic state, so we had a lot of events in the past. One of the recent one is the Northridge earthquake. So at that earthquake, a lot of hospitals unfortunately got yellow and red tagged, and there's a good number of percentage that that had to be evacuated or the function got affected. More recently, there was a big earthquake in Turkey back in February. So we really observed the hospital, the functions behind it, and how the hospitals interacted. So it was a really good and it was a good example for California, but it was really sad to see the struggle that the country went through. So why are we bringing this example? Turkey is very similar seismically to California. They have major fault lines and several minor fault lines across the country. Again, very similar to California. This shows the active faults that moves every day. And if I point out the San Andreas fault, the biggest one, it moves about more than an inch every year, and everything else is quite active. So if I put California and Turkey side by side, they are not only similar in size, but also the fault line slip rate, age, length, and straightness is very similar. So the seismic risk that these two regions are really alike. Back in February 6th, a 7.8 magnitude event occurred in Turkey, and this was a huge earthquake. And 11 minutes after the first earthquake, 6.7 occurred. So for big earthquakes, it's very common to have multiple big aftershocks. So once a building goes through a large shaking, typically the expectation is there will be subsequent motions that the building has to endure. So 6-point event occurred as an aftershock. And just to give you a relative sense of how big this is the Northridge size. So 6.7 was the Northridge earthquake. So the aftershock of the 7.8 was pretty much the Northridge earthquake. 9 hours later, 7.7 magnitude event occurred. Again, this is not uncommon. Once something big fractures, then it may trigger another fault line connected to it. So that's what happened in that event. And 2 weeks later, 6.3 event occurred at the south side of the country. So when we combine all of those, this shows the acceleration map as you go towards the center, the shaking intensity increases. So this area is the most affected, and as you go outside, the effect gets less. That doesn't mean that nothing happens. Still, the effect is less. So let me go back one slide. So what I did is just to give some sense of the magnitude as well as the logistics of this earthquake, I took these contour lines, and without scaling, I just put it right on Southern California. So I tried to match where the San Andreas Fault is, and I just put it on Southern California. And again, this can happen anything along the state if I follow the San Andreas Fault. Again, you know, it's not one-to-one thing, but again, just to show you how the logistics would work if this happened in Southern California. So we have a border with Mexico, Arizona, and Nevada. So it's really the border, all three sides of Southern California is really restricted in terms of healthcare. Now, when this big earthquake comes, these green dots are skilled nursing facilities and general acute care facilities. And this red contour, which would be the highest, I would say the most affected area, half of our general acute care facility inventory would be highly affected. So 230 facilities would be within this zone out of 414 across the state, and 620 skilled nursing facilities would be highly affected. So the reconnaissance that I participated back in February, what we saw is within this red line, the hospitals were most affected. Structurally, non-structurally, a lot of broken pipes. So this is the region that many things will be affected heavily. So if you can picture this scenario, a lot of general acute care facilities and skilled nursing facilities would be going into emergency state. So a lot of resources are needed to fix things. A lot of resources are needed to provide water, electricity, emergency generators, gas, so and so forth. So because of these kind of scenarios, there is MPC-5, so that the hospitals can reasonably function within the hospital borders. MPC-5 is about buying time, so that the 72 hours of fuel, water, wastewater, those are about buying time, so that after 72 hours, there will be some fixes coming in, the resources are coming in, the help is really started getting coordinated. What is the likelihood of having a very big event in California? So this is a study done by USGS back in 2015. So for another 6.7 magnitude event in the next 30 years is about 93%. A 7 event is 75%. A 7.5 event is 36%. An 8 event is 7%. Northern California has very similar table with few percentage off. So the likelihood is the same for Northern California. So if I shift these contour lines into the Northern California, the picture, the other half is really affected as much as the Southern California. So with that, I'm gonna go into some definitions because we were gonna be using a lot of acronyms and different definitions throughout the presentation. So first of all, the Seismic Safety Act basically put the really the basis of what we are doing. So it requires that the hospital shall be designed and constructed to resist, insofar as practical, the forces generated by earthquakes, gravity, and winds. So the guide that Kamal will be showing is really giving you some practical aspects of how we can design to NPC5. So I want to point out that in order to have a functional facility, we really need to consider three things. You know, in these webinars, we talk about only one thing, but just if we step back, we really need to understand how a successful outcome can be achieved. And it is really three things. The first thing is structural. When we mention structural, what we mean is just beams, columns, shear walls, slabs, foundations, the major carrying system. So, and we have a category for that. It's SPC, Structural Performance Category. And let me step back a little bit. So I'm not showing any walls, like partition walls and things like that. So those are not structural. These are structural items. When we say non-structural, what we mean by non-structural is cladding, partitions, ceilings, equipment, pipes, furnishings, content, elevators, stairs. So everything in the building that makes you know, serving the patients. And we have a category. It's called NPC, non-structural performance category. And this is the facility side, but what makes things all work is staff. So let's not forget that staff is also victims of the earthquake. So they go through a huge trauma with the earthquake, and you know, seeing all the cracks around the building. If staff can function, then structural and non-structural, you know, it doesn't matter how good we do. You know, there's the third and most important part that really makes things happen. So with these three, then we have a functioning hospital. These are photos from the earthquake in Turkey. So this particular example, the structural SPC, the structural side in this hospital in Turkey, actually did very well. The columns, the beams, the slab, the foundation, everything was really, really good performing. However, the non-structural side, the partition walls, the furniture, the equipment, the ceilings, the distribution system, unfortunately, it didn't do well, and it ended up being evacuated. So again, the non-structural side of things are as important as the other two. So for the non-structural side, we have 6 categories. NPC 1 is the worst, NPC 5 is the best. And there are steps on how to achieve on each one of them. A couple months ago, I gave a presentation that talked about 2, 3, 4D, and 4, and 5. So there's a lot of good information in that webinar, and the slides and the video is available on our website. So if you want to go back and look at that. But today we're going to focus on NPC 5 only. So rather than reading all these items, I'm going to just show something a bit more visual to explain NPC, what NPC is. So let's say this is a hospital building which has admin, ICU, med-surg beds, radiology, and emergency generator at the basement, chiller, and obviously with multi-story there are stairs and elevators, and there's some communication system. So what makes hospital work? Obviously, we have electric, gas, and water coming with the bulk oxygen, and everything is tied with a bunch of pipes, conduits, ducts, and the hospital functions with this. So if there's no bracing or no evaluation of bracing, we call this building NPC1, meaning that nothing is evaluated and or it's not nothing is braced. So that would be an NPC1. The NPC2 brings in and anchors bulk oxygen, emergency generator anchoring, some fire alarm panels, exit signs, some lights, and some communication systems. So that would get NPC2. And if you want to go to NPC3, certain critical care areas gets braced within the boundary. So this, for example, if we take this ICU room, there will be some braces on these pipes, but not braces all the way around it. So NPC3 basically makes sure that the, things don't fall on the patients, but that doesn't mean that the room will be functional. NPC4D level 1 is basically NPC3 with our operational plan stated. NPC4 is basically looking at the entire building and brace what's needed to make sure that it remains functional. And NPC5 is really focusing on water tank, fuel tank, sewer tank, and the design around how to come up with the values of this. In order to get an NPC5, the building has to be either NPC4D or NPC4. So you cannot have NPC3 and then go to NPC5. So you need to first go to 4D or 4 and 5. So so that's the NPC rating. The SPC rating is also important to understand to have really a strategic plan for the facility. So if you have SPC 1 or 2 in your facility, those do have deadlines associated with it. At SPC 3, 4, 4D, and 5, those buildings, rated buildings, can continue past 2030. So these buildings, those are post 1973 buildings. So if your building is 50-year or younger or newer, then those are conforming, structural conforming buildings. Any building older than 50 years, they would be in this category. Unless you put an upgrade, when you upgrade SPC 1 to 1, 2 to 4D, then you can just continue beyond 2030. So with those definitions, you know, NPC as well as SPC, what do we have in our inventory today? So this is, let's see, 2 weeks old data. So we have about 46 SPC1 buildings, about 700 SPC2 buildings, and the rest is conforming buildings, 3, 4, 4D, and 5. Out of 3,300 general acute care buildings. Well, let's look at NPC. We have a few facilities with NPC1. About half of our inventory is NPC2. And the rest is 3, 4D, 4, and 5. So the slice of 5 is growing pretty rapidly as we getting some evaluations or just justifications that the building is already as NPC5. All right, so how can you find this information? How can you check where you are on the facility? So the best place to go is to our website. This is our the link. Put the facility name, so that will be the facility information, and then click on the building list. When you click on the building list, it gives you a lot of information about each building in the campus. One thing that I suggest you to look at is one is expansion NPC extension date. Some facilities are high seismic region, so they need a little earlier. They're subject to earlier deadline. But other than that, the SPC NPC rating is stated right here. So what are the deadlines? There are some other exception deadlines, but the majority is by January 1, 2024, complete non-structural evaluation is required to be submitted for MPC 4, 4D, and 5. So by 2026, the construction documents needs to be submitted to the office. So I want to pause here a little bit. By the end of this year, the requirement is not to be NPC 5, NPC 4, or 4D. The requirement is to submit an evaluation, meaning that the design professional looks at the building and identifies what is compliant and what is deficient, and put it in the NPC 4 and 4 or 4D report. And same for NPC 5. The design professional looks at the building, looks at how much water is needed, how much water, wastewater, fuel is needed, and what's the capacity on hand, and what is the need, what's the delta. So that's the evaluation deadline. By 2026, with that delta in mind, okay, let's say I need 10,000 gallon tank. Then the design professional prepares construction documents detailing, the location, the place, all the design, and submits to the office. And by 2028, that's the deadline to get a building permit. So after this, then the hospital not meeting this deadline, the HCI won't issue a building permit except for seismic compliance, maintenance, and emergency repairs. And by 2030, the GAC building shall achieve NPC 5 rating. Well, what about the buildings that will no longer provide acute care services beyond 2030? So we get these questions a lot, like, I'm not planning to continue with this building. Why do I need to do all these evaluations and upgrades? And if I'm certain that I'm not going to use this building for GAC purposes. So there's a path for that. So if the building is, let's say, MPC2, it can remain as MPC2 if you just give us a compliance plan saying that this particular building will not be used beyond 2030 for GAC. Once you do that, seismic compliance unit will place that building in a separate track, in a separate bin, to basically not trigger the 2026 deadline. Now, again, if the intent is to remove acute care services, then there's a 2028 deadline to submit that intent, construction documents, a removal of acute care services project, so that we make sure that that building is off the GAC functions by 2030. So I hope that this kind of gave a good overview of how we are, or why we are approaching MPC 5 this way. And with that, I'm gonna turn to Kamal to explain all the details about MPC5. And once he's done, we will switch to question and answers. Kamal?
Okay, can you hear me, Ali?
Yes.
Okay, can you stay to let me know when you can see my screen before you mute yourself?
All right, not yet. Yeah, we can see your screen.
I will be showing your last slide probably at this point.
Yes, and if you go to the next slide. Yep.
Okay, perfect.
Go ahead.
Thank you, Ali. Okay, I'm glad that this went well, as we were not sure if switching presenters in the middle of the presentation was going to be an issue. So now that we are done with the hard part, let's move on to the easy part, NPC5. Also, we are not planning to have any breaks in between. So if we finish early, we'll hopefully give you that time back. Okay, so in this next portion of presentation, we'll go over the NPC5 requirements as it relates to the code. We will discuss the online advisory guide A5, which we have on our website, and as Ali mentioned, was recently updated as of yesterday. And go over it to see how it helps in preparing the water rationing plan. We will discuss the water and wastewater requirements as it pertains to the water rationing plan or water conservation plan. Also, we'll try to cover what CDPH is looking for in the water rationing plan, especially as it relates to the hospital functionality and services that the facility chooses to remain operational during an emergency. We'll try to go over an example case and also some frequently asked questions. So as Ali mentioned before, the deadline for NPC5 compliance for all buildings is 2030. But there are milestones that are coming up, and the closest being the end of this year for NPC5 evaluations. So an NPC5 compliant hospital facility is capable to support 72 hours of emergency operations during a widespread damage caused by major earthquake. With all major earthquakes, we have seen widespread damage to not only buildings, but critical public infrastructure as well. The intent is to treat the hospital facility as an isolated place which is self-sufficient and reasonably capable of providing services after disaster, especially in the initial time before help from outside can start. So the question becomes, what is being reasonably capable of providing services to public after disaster mean? For our purpose over here, we are looking at 4 main items: water storage, wastewater storage. These two first items are coming from the water conservation or water rationing plan, which we are going to discuss today in further details. The item 3 is the fuel storage for emergency generator or the e-power. And lastly, bracing lastly, bracing of the utilities and systems. So you need braced utilities and components that is the NPC4 or 4D part to achieve NPC5. I think Ali mentioned about this in his presentation as well. If things are not braced, then this doesn't work. NPC 5 looks more towards functionality and resiliency of the building, rather than just the anchorage. This picture is from Northridge earthquake, showing a ruptured supply line that caught fire on Balboa Boulevard in Granada Hills. A lot of water mains and gas lines break during an earthquake. This is way more common than people think. Northridge was a magnitude 6.7 earthquake. This picture is from the 2014 Napa earthquake, which was a smaller earthquake. Well, smaller than Northridge. I believe its magnitude was 6, if I remember correctly. But still, it resulted in 120 water main breaks. So as you can see, there is extensive damage to the infrastructure. So damage to water and wastewater systems basically results in loss of service for extended periods of time. The crews work 24/7 after an earthquake, but generally big earthquakes bring hundreds or thousands of broken lines and gas leaks. It takes time for the crews to get things fixed. Also, as Ali was mentioning, for staff, one thing to remember is even the local crews who are helping fix this are also personally affected by earthquakes. So there is going to be staffing issues which might result in delays while the emergency crew from outside are able to arrive and help. It also affects transportation, the roads. So even if the crews are there, sometimes it's difficult to get from one place to another. So therefore, the hospitals are required to have or enough resources on site so that these things are being, while these things are being repaired, the hospital is functional and is able to provide services to the public, especially those in critical condition after a major disaster. One important thing to remember, and again, I believe Ali mentioned this, is that all NPC 5 is doing is buying time and nothing more than that. It's buying time till supplies or help from outside can start coming into the hospital. Okay, so hospital water utility failures can be triggered by multiple unforeseen conditions. Water is very critical to hospital functioning and maintaining services for the patients. As you can see, there is a big list of consequences of water loss in hospital after an earthquake. For patient care, as an example, hemodialysis, hemofiltration, hydrotherapy require water. Loss of water would result in infection issues, sterilization issues. A lot of hospitals and facilities rely on cooling with water chillers, so HVAC system. If they don't have water, would affect the cooling and temperature control of the facility. Similarly, laundry, fire suppression capabilities, drinking water, sanitation services. Another important one is the inability to provide effective hazmat decontamination response. So as you can see, there is pretty severe consequences in the functioning of an hospital if there is no water for the hospital to function. So that was a overview. Now going into the code requirements. The code requirements are listed across multiple locations. California Administrative Code provides definition of NPC 5 building, and also the timelines or the deadlines. California Building Code has NPC 5 requirements for new construction, which basically states that new building needs to be complied with the NPC 5 at the time of construction. California Plumbing Code has information on minimum water requirements under Chapter 6 and wastewater requirements under Chapter 7. One thing to note, as with any other code section, there is always good information listed under the exceptions and footnotes, so make sure to take a look at them. So California Administrative Code has a definition of NPC 5 under Chapter 11, Table 11.1. It essentially states a building that has its non-structural components braced, that is NPC 4 or 4D, and has on-site supplies of water and holding tanks for sewage and liquid waste, sufficient to support 72 hours emergency operations, and are integrated into the building plumbing systems in accordance with the California Plumbing Code. There is also discussion on the e-power requirement as it's shown in the text, which is not highlighted in the slide. Again, the intent of an NPC 5 facility or a building is to have the facility self-sufficient without any external resources for the initial 72 hours after disaster or an earthquake. So now trying to understand what's required for emergency water storage. In California Plumbing Code, there is a clear distinction that NPC 5 requirements include both potable water as well as industrial water or the processed water when it refers to the water requirements for the 72 hours of emergency operation. Furthermore, there in the California Plumbing Code section 615.4, there is clarification on the minimum amount of potable water requirement as it pertains to the number of licensed beds. It requires a minimum of 50 gallons per day per bed, which comes out to be 150 gallons for 3 days, and that's 72 hours. Again, this is specifically for potable water, and in the presentation going forward, we'll discuss the non-potable water discussion as well. The code requirements are same for new versus existing buildings, as all of them are required to be NPC 5 compliant. The timelines are different. The main difference being that the existing building that remain in acute care inventory are required to be compliant by 2030. Again, as we previously mentioned, to make sure the deadline is met, there are timelines in California Administrative Code that are coming up to keep the process on track and not to push the required work down the road when it becomes too late to comply with the requirements. A big difference between existing and new building as it pertains to NPC 5 requirements is that new buildings are required to be NPC 5 at the time of construction. So when you submit a plan for new construction, we will automatically flag it in our system to check if it meets the NPC 5 requirements. Again, the code requirement as it pertains to amount of water in gallons remain the same, which goes back to the water rationing plan. So what to do for central utility plants? It sometimes gets a little confusing as central utility plants don't have beds. So for central utility plants, they are required to provide water for 72 hours for itself and any other new building under construction it will be serving. Central utility plants are not required to support the existing buildings on facility campus. Again, that does not prevent the team from providing the water to the existing buildings. It just needs to be calculated in the design. Again, nothing's prohibiting installation of larger tanks. So for example, a new central plant has a water-based chillers installed. They are serving the new central plant itself and one new building on the campus. The existing chillers for existing building on the campus can remain as it is. So to meet the NPC 5 requirement, there should be water provided to meet the requirements of the two new chillers that are serving the central plant, the new solar central plant, and the new building on the campus. But you're not required to provide water for the third chiller at this time, which is serving the existing building. But again, that's something that need to be calculated and provided for the 2030 deadline and end of this year kind of timeline for preparing the evaluation report. As always, the fun stuff is in the exceptions or footnotes. So there are exceptions under California Plumbing Code. Section 615.4 allows smaller tanks where alternate arrangements have been made for delivery of water. So what this exception is doing is allowing to reduce the on-site water requirement from 72 hours to 24 hours, as long as alternate arrangements are made for the remaining time. Again, the minimum on-site needs to be calculated under the water rationing plan and shall not be less than 5,000 gallons or 50 gallons per bed. Similarly, section 727 allows alternate arrangements to be made for transportable means for sewage and liquid waste disposal. Note that where these exceptions are used, the arrangements will require both HCI and CDPH approval. So in California Building Code, Chapter 16A, there is an exception permitted for general acute care hospitals with building area less than 4,000 square feet. This exception could still be utilized, but all acute care buildings require their own water rationing plan by the end of this year. So if you're planning to achieve compliance by a campus-wide water rationing plan separately, it might still be something you could use. If you're not performing a campus-wide water rationing plan, then you will require a water rationing plan for the building to be considered at the time of construction anyways. Another item listed under the code section, this specific code section in CBC 16A is for e-power. Emergency and standby generators shall not be located below the higher of design flood elevation or base flood elevation plus 2 feet or a 500-year flood elevation. I believe this requirement has come after the Japan earthquake. There is another line item in the code which also requires that these be located at an elevation close to grade for easy accessibility from outside for maintenance. So now going from general code requirements to water rationing plan. So how much water does your hospital need in an emergency? Unfortunately, there is no simple answer. Every facility is different. They provide variety of services for public, and the resources in the facility are different. Sometimes there are site restrictions, but a lot of time there are budget restrictions as well. It is a very comprehensive question, and the idea of water rationing plan is to reduce the amount of water needed so that the required tank that needs to be installed becomes smaller. Water rationing plan needs to be thought out and worked with the facility and not just the design professionals, which is very important. Working with the facility, you can come up with the rationing plans. It's a function related plan, and it depends on the services chosen by the facility to provide under emergency. It will all depend on the emergency operation plan and the associated water rationing plan. So going forward in this presentation, we're going to discuss how to prepare water rationing plan while working with the facility. So approvals are required by CDPH, which is the licensing division. Again, the minimum volume of potable water required per licensed bed is defined in California Plumbing Code, but the minimum amount of industrial process water is not defined in the code. So to come up with what amount of water is required there, we need to understand which utilities and systems the hospital facility intends to operate during an emergency, and also the losses that happen in the process water for closed loop heating and cooling system. There are evaporation losses, and from what I understand, blowdown, which happens every so often. So working with the mechanical engineer to figure those out. Again, to re-emphasize, the details in water rationing plan really dictates how much water is required. We published a guide last year to answer some of these questions and help facility put together a water rationing plan. This is not a required format, but this helps facilities because a lot of facilities don't know where to start. Although the basic requirements are there, it's just how to put together that plan. As I mentioned, this was published a year ago, but it was recently updated. So please look at the recent version as it has some good updates in there. The water rationing plan is based on multiple items such as normal operating conditions, what kind of resources you have, what are the water uses in your building. The guide asks these questions to help start shaping your plan, and then depending on the function that you can provide during an emergency, the water requirement can be calculated. There are also discussions on tanker trucks, heating and cooling in the guide. Again, HCI and CDPH approvals are required for all water rationing plans. We will initially review the water rationing plan. Once major comments are resolved, and submittal is then sent by us to CDPH for their review and approval. We have another slide later to kind of go in more detail about the submittal and approval process. So the update is there online. Always check the website for the latest document. It applies to not only this guide, but in general when you're looking for pins and cans. All these documents get updated very recently as we get more information. So I know we sometimes like to save PDFs, but it's good practice to always go online and get the latest version. So it's up there. There are no new requirements. Again, the code hasn't changed. All we are trying to do is give you more information to avoid further back checks and going back and forth with us or CDPH. So all we are trying to do is provide more guidance. There is a section on frequently asked questions that's added. Again, the most commonly asked questions we thought would be a good idea to include this in the guide so that if you have those questions, you can look at them. We also included a CDPH internal checklist. This is not available online for public, but we discussed with them and they were okay with us sharing it. So we have included it in our guide for your reference. There was a lot of discussion on industrial water. So we included that as part of the updates in our guide. A lot of summary tables a few more summary tables were added. There were already a few summary tables, so this kind of part of the portion was a little improved in the guide. There are a few minor editorial changes. Again, Ali and Patrick helped a lot on this. So I'm gonna go talk more about the guide and how it helps you prepare for the water rationing plan, but want to mention that there are other resources as well. CDC has an emergency water supply planning guide. It's an excellent document, very detailed, so you can use this one. And not just this one, there are other really good sources, national sources out there that you can use to prepare a water rationing plan. You don't have to follow what we are saying in the guide. So, as I said, this resource is very detailed and helpful. So please feel free to use other resources that are available. So now I'm gonna try to kind of focus on how we have our guide organized and how it helps in preparing the water rationing plan. So when you submit your water rationing plan, we are asking to include a brief list of items, as you can see in that table shown on the slide. Sometimes when the whole campus plan is submitted for review, it becomes more critical to see all the buildings to make sure all possible water usage is accounted for. You can find the site maps that's shown in the slide from our website. If you see any discrepancy in the site map, please reach out to us at Seismic Compliance Unit. If your sitemap is incorrect, there might be issues later when water rationing plan is submitted for review. So it is best to resolve these issues before, as the deadlines for campus-wide work are coming up. When I say discrepancies, like things such as making sure non-acute care buildings are clearly identified on the site plan so there's no confusion. Also, sometimes when there is a seismic gap, but the plan still shows the building as one site map is a common thing. It probably doesn't make a difference architecturally, but structurally, we want to make sure that's represented correctly because each building has its own rating. So the documents that we are requiring for review of the water rationing plan, we would like to see an executive summary. We'll show a table of what it looks like, but in the water rationing plan, the executive summary, we would like to see what is the existing water and wastewater storage capacity already on site. What would be the additional proposed water and wastewater storage based on your water rationing plan, which kind of ties into the third point here, which is the anticipated emergency usage, which comes from your water rationing or conservation plan. Then the important thing that CDPH is looking for is what services that are affected under your rationing plan during this emergency, and also including information about water replenishment, tanker trunk arrangements that have been made to continue the 72 hours of operation. We are also asking to provide diagrams showing the shutoff or the redirection wall locations. This becomes important because in part of your emergency plans, you might have plans to shut off services to certain portions of the building which are not critical. So we want to see those shown in the plans. We have listed architectural floor plans showing services here as an optional, but again, if that helps us and CDPH understand your emergency plan, please include that. But as I said, it's optional. All the supporting calculations, the capacity calculations, as you do work through your rationing plan and come up with the amount of water, wastewater. So we would like to see those. And the on-site fuel supply calculation as it pertains to e-power. Okay, first thing to start when preparing a water rationing plan is to look at the existing water bill. This gives us a good starting point on what the current usage of water is and how much rationing or conservation of water will be required during emergency to meet the facility goal of providing the chosen services. One thing most likely you will notice is the variation in the water usage during different months. As you can see in this snapshot here as well, especially if you are in a hot climate inland. For example, the usage will probably be large if your facility is like located in Palm Springs or Fresno, which is inland, away from a moderate climate, in such as in Bay Area, because there is a huge demand of water for cooling, assuming these are water chillers, of course. So there will be a difference in summertime versus wintertime usage. This would also give you, this difference would also give you a good idea on what your industrial water is. Not all facilities have water meters at multiple locations. So, most of the facilities have only one water meter, so it becomes hard to distinguish the water usage between different buildings, or even, if you have a non-acute care building on the campus, how much water does that use? So there will be work needed to be done after, but this is a good place to start from. We highly recommend looking at the water bill first. So also another item to look for is irrigation demand. Again, if you have a shut-off wall, this demand can be easily reduced in your emergency operation plan. So in the guide, we ask you to kind of, when you're done with the calculations, put all this information in a very concise table so that it's clear what's there, what's proposed. So for example, this table over here shows what is your existing water tank capacity, what's the new water tanks capacity that you're proposing. Are you going to be using any wells that are on site? I'll talk more about wells on the next slide. And if there are any other secondary emergency water supply, like bottled waters or other stored waters. Again, as I said, look at footnotes. There is a lot of information there as well. But if you have more questions, always free to reach out to us. So going to on-site water wells. You can probably, Ali can talk about this a lot more than I can, but the wells or on-site water does way better than other means of replenishment when it comes to tanker trunks. They are way more reliable. This was also seen in the recent earthquake in Turkey. So again, we are asking you to see if you have that option, please use it, or try to use it. All we are asking for at this point is average gallons per minute that could be used for design. We are not asking for minimum. We understand there is climate change. There are droughts. There apparently there are hurricanes now, but so yeah, there things are changing for sure. So again, we are not gonna be questioning you on the worst case drought scenario or things like that. All we are asking for is the average output that you can get from the wells. With wells, as you probably know, water quality is one thing to look into. So like any other thing, you'll need a filtration system to make sure the quality standards are met. Pumps and filters need to be on emergency power, because there is high probability of losing power as well during emergency. So we want to make sure that water could still flow and be used even if the power is out. Similar to any other use, you need to have holding tanks where the water could be stored and then given to the facility. For this case, the outflow can be considered similar to a tanker truck for replenishment. So it's a pretty straightforward calculation as far as that's concerned. So now moving on to kind of identifying the water uses in the building. We put a list of possible water uses in a building. You can just see what applies to your case for your facility. You know, we understand that you're making assumption and it's not exact science. For example, water required for sterilizer could be based on number of cycles run in a day and the gallons of water used per cycle. Similarly, laundry loads and the amount of water used per cycle will provide a good estimate of water use for that case. We tried to list multiple items, but since every facility is different, please discuss with your facility and include all applicable water usage sources that applies to you. So for plumbing fixtures, we have a more detailed table under our appendix for your use. There are some good rule of thumbs out there. Put some numbers to these things. We are not challenging that it's a 2 gallon per flush, not 1 gallon. Design professionals can make that assumption, and then we'll just go with that. We have some tables to expedite how to just put something together. Again, discussion with facility on a number of staffs, daytime versus nighttime, expected number of patients, and so on. During an emergency, all these things need to be discussed so that you can come up with a good estimate. Water quality. This is a Title 22 requirement, not HCI, but a CDPH requirement. So what it states here is water for human consumption from an independent source shall be subjected to bacteriological analysis by a local health department. And it says something like at least every 3 months, and the copy of the most recent lab report should be available for inspection. So these quality tests are required to be done periodically already. I want to point out that we are not requiring, or nobody's requiring at this point, to perform these tests when an earthquake hits. You are we understand you're not going to have access to a lot of things during emergency. So what we are asking is designing your system with the quality testing as you already do, and if it is possible during the earthquake, then testing might be a good idea. So right now it's your typical water quality maintenance on a daily basis and how it's done, nothing new. If you have any additional questions about water quality testing, please contact CDPH as they would be in a better position to respond. Okay, the fun starts. Tanker trucks. It's a interesting topic, and in pretty much every earthquake, when the earthquake hits, these trucks are in very high demand. When the city water goes down, everybody wants water. So we need some pre-planning to make sure that the hospitals get what they need in an emergency. So we need to do a few preparations. We need to identify the connection locations for potable and non-potable water. A lot of times the hospitals grow over time, and sometimes these connections might get lost in between those designs. The tanker trucks access to these points might not be still feasible. So make sure that you have locations on the plan that would allow for your driving up of the tanker truck and hooking up and providing the water replenishment as you plan. Another thing is indicate connections and refill time in your report. Please note that the tanker truck hookup, plumbing, pumping the water into the tank and then disconnecting the lines, all this takes time. Too many tanker trucks per day may not be feasible to execute. If you see that you are getting a huge amount of tanker trucks number, consider increasing your water storage capacity. And there is no I think internal we think that anything less than 2 hours of frequency is not feasible. So just look at it to make sure that the plan could be executed. Typical tanker truck size is 4,000 gallons, so this could help you in calculating the number of tanker trucks required and their frequency. Again, it's not just the hospitals looking for water. Probably everybody is looking for water in emergency, so we want to make sure that the hospitals are prepared. We would like to see the name of the company who has the contract for the water tankers or the water replenishment. So we don't need to have the actual contract, but we need some information from the contract. So please tell us who you are contracted with and how who is going to monitor the contract and where are they going to get the water from. We understand it's not certain at this point about where they're going to get it, but at least they should have a plan of where to ask for in an emergency. So California Plumbing Code section 615.4.2, there is a requirement and it says that the emergency supply of water shall be delivered to the endpoint of usage at sufficient pressure from the storage tank. You can achieve this sufficient pressure by gravity. Excuse me. Pressure tanks or booster pumps. Gravity might become expensive if to in certain cases. So we have seen booster pumps as a typical way of achieving this. And if booster pumps are required, again, they need to be connected to the emergency power supply for the same reason, because there is a high probability of when infrastructure problems start to happen, there might not also be power on site. Okay, so far the discussion has been on potable water. So now switching to industrial water. This topic of water requirement for industrial water has brought very interesting conversations in the past few months. So usually facility needs water for cooling if using water-cooled chillers. Water is needed for heating for boilers. Also, it's needed for humidification. Of course, heating and humidification more likely during wintertime and cooling in summertime. But based on the information we have seen so far, the biggest source of water is for cooling in a water-cooled chiller or in a facility that uses a water-cooled chiller. There is sometimes a very significant amount of water requirement for cooling, which where it becomes unfeasible to install such large tanks to maintain building temperature. With a few of the projects we have seen, it's not uncommon to see even close to 200,000 gallon tank size required to meet just the industrial water requirement. So to understand your emergency plan, we are asking if the facility is planning on limiting heating, cooling, and if they are, what services will be affected by that? And also how the facility will monitor and maintain adequate humidity, temperature, and air pressure. Please use the table that's provided in the guide to include all the relevant information. If needed, you can use site plans showing the departments which are affected, if you think it would be helpful for review or to understand your rationing plan better. Okay, so based on the CDPH discussions, the CDPH recommends at a minimum the facility should provide industrial water to heat, cool, humidify, number one, operating rooms, and item number two, temperature sensitive drugs and medical supplies. We, again, this want to make sure this is recent, so this is an update, well, not necessarily an update, a clarification that we have gotten. Again, if things change, we'll let you know, but this is what we understand from CDPH. So again, operating rooms and temperature sensitive drugs and medical supplies. We understand in majority of cases, it's not possible to only provide temperature control within certain areas, since the cooling units usually serve the whole region. As such, if the facility decides to limit the water use to only these critical spaces, please include within your report how the cooling can be isolated to these regions, because we just don't want to, we want to make sure there's a plan. Just saying that you're only using water for operating rooms and temperature sensitive drugs, but if these rooms cannot be isolated, then you will end up using the water a lot sooner, because the whole facility or the whole region that the chiller is serving will be still working and using water at much faster rate. There are other alternates, such as air-cooled chillers and DX units, which serve smaller areas. That could be a solution for a few facilities. So that is something to look into. Also, the water rationing plan shall include inflection control measures for CDPH licensing and certification reviews, especially when cooling is only limited to these regions, since the temperature can rise beyond permissible range of some, for example, surgical apparatus. The infection control becomes a concern at higher temperature. Again, this is our most current understanding based on the information we have received from CDPH at this moment. If anything changes, we will notify our team, either by updating our A5 guide or through the plan review process. For cooling, humidification units serving these spaces not connected to essential power, HCI recommends, not requires, having alternate power source arrangements to maintain design temperatures per the California Mechanical Code Table 4A. Again, it's our understanding that the code requires e-power for ventilation and heating, but not for cooling or humidification. Some facilities have a certain portion or all of their units on e-power as a good practice, but not all facilities, unfortunately. Again, we want to emphasize we are only recommending having alternate power source arrangement. We are not requiring it. Okay, now going to the impacted services in the building. So, when an emergency happens, it is very difficult to say that everything will work just like, nothing happened and operations are going on as normal. It is just not practical. We understand some services will be affected, and you're going to try to save water. So that's why it is a water rationing plan or conservation plan. What we are trying to say in this plan is, okay, these are the services, that will be affected. Basically saying, okay, tell us what you are expecting to remain fully functional or partially functional or not functional. If there are areas you can do without water, like those admin spaces, then that's something where you can reduce water use without an issue. But when it comes to basic services, then it becomes more difficult to just say that we are not going to continue the service, or we are going to go code dry, for example. Generally, this CDPH is pushing back on that statement. So what we recommend is looking at these services and aim for something less, not eliminate, but something less, somewhere in between. That we have seen that generally goes much smoother because you are continuing services in a less capacity, and that is understandable under an emergency. So again, what's the magic number? We don't know the magic number. It's a discussion with the facility on a case-by-case basis. Again, the design professional need to work with the facility representative and their emergency response team to make sure everyone's on the same page as far as operational services are concerned. This is there is a little modification from the last time in this table. There is now a new column for temperature control. As we just discussed, since the water demand can be very high in some cases, we want to clearly distinguish this in the table and understand which building services will be outside the temperature range permitted by code. You can see in the footnote in California Mechanical Code, there is a table 4A which lists the permissible temperature range. There are some further considerations that we put in the guide. Some of the questions that you see are coming from CDPH. That doesn't mean that you're going to get the exact questions that you get every time. We included some of those in frequently asked questions. Again, these are not necessarily HCI questions. For example, impacts on compounding, oral, IV, clean rooms, etc. So those are some questions that you might see, and a lot of times actually there are some easy answers. So take a look at it and put it in the plan so you don't have to go back and forth. Again, this CDPH has previously asked about pharmacy, dietetic, life safety code in the previous reviews of water rationing plan, when such information was not included in the original submitter. So again, we are trying to give you as much information upfront as possible in terms of what CDPH might be looking for, so that you can include this in your water rationing plan, again, to avoid back and forth with them. So we're going to switch gears again. So we talked about potable, we talked about water, both potable and industrial water. Now we are switching to wastewater. Hospitals discharge considerable amounts of chemicals and microbial agents in their wastewaters. Many of these chemical compounds resist normal wastewater treatment, so making sure these chemicals don't go into the soil or other places prior to proper treatment is important, as these can, start affecting the food chain. Some chemicals are also, from what I understand, known to cause resistance to antibiotics. So again, the California Plumbing Code, section 727, which is chapter 7, requires emergency sanitary drainage to support 72 hours of continued operation in event of emergency. Having a sewage overflow would probably be the last thing a facility would want to see. Okay, so for new acute care hospital buildings, you're required to have on-site holding tanks to store sewage and liquid waste sufficient to operate essential hospital utilities and equipment in the acute care hospitals. For existing, the requirements are the same, but by January 1, 2030. Again, milestones are coming up, but the deadline is January 1, 2030. In California Plumbing Code, it states that the emergency waste holding capacity needs to be based on the water conservation plan or the water rationing plan. There is no more guidance than that. There are exceptions for waste water storage, and one of them is leak-proof bags. These are basically very big bags that you can store on site, and you can just roll it out when an emergency happens. There is a lot more flexibility in wastewater as compared to water tanks. You can use this on different places as long as you have hookups. You can perhaps reuse these bags depending on how you work out your water rationing plan. The location of leak-proof bags is a whole lot easier compared to the water pot. There are further requirements on the locations, but again, we will work with your team depending on where you want to place these things. We want to make sure there is a good plan in place for these leak-proof bags to be stored and executed. Code required lockable rooms and lockable screen enclosures of adequate capacity to store the quantity of wastewater anticipated for washing and cleaning the containers and for storage of sewage and wastewater. Again, this can be on floor with a curb, a sealed concrete floor, or another approved impervious flooring with a curb and with a drain connected to the sewer. So a lot more easier, a lot more giving than what water requirements are. A few things need to be planned when it comes to reusing and washing. So check with your local health department to see if your proposed plans are okay. We are not necessarily questioning that, but again, so far we haven't heard any issues from other departments either. So this is again a summary table we would like you to include in your water rationing plan. Once you have all this information about existing wastewater tanks, new wastewater tanks, any leak-proof bags. This is similar to the water summary table we had. Again, this helps summarize your plan so that we can take a look at it in a more concise format. So there is no minimum size for holding tanks provided in the California Plumbing Code. The capacity shall be based on water rationing plan per CPC, the California Plumbing Code. We do recommend a minimum size of 24 hours for holding tanks. So again, we just want to make sure there is enough capacity on site to be able to maneuver items when the emergency happens. So that's why it is our recommendation to have at least 24 hours of capacity when it comes to holding tanks. The purpose of the holding tank is to permit 72 hours of continued operation if the external sewage connection is damaged. There are no HCI requirements for connection of the holding tank to the existing sewer line, but the connection should be made with sufficient walls to isolate the external sewer lines. Again, we don't want overflow coming from the city lines back to us. So use of there are certain requirements as far as leak-proof bags are concerned. They should have adequate storage, local NCDPH authorities approval, and they should comply with the requirements of lockable screen enclosure and so on. So that was wastewater. So we talked about water potable and industrial, and we talked a little about wastewater. Now going into example, this one over here is of a facility in Southern California. So this is from the actual facility. So for this facility, as an example, the overall consumption from the existing bill we saw came out to 225,000 gallons per day per facility. Again, this is an average number per day. There is variations to that, summer times versus winter times. When we look at that in terms of number of beds the facility had, so the per bed consumption came out to be 465 gallons per day per bed. When we looked at the same facility for square footage consumption, it was close to 0.28 gallons per day per square foot. This is an average facility or more average representation of facility that we choose here. And there are facilities that have higher consumption than this, lower consumption than this. So we wanted to give you an example of what on an average facility in Southern California looks like. Again, the summer water consumption for this facility was nearly twice as compared to its winter water consumption. And then this numbers over here included the irrigation demands. Irrigation demands actually range a lot. They range from 2% to 30% in some cases. I believe for this facility, which is shown as an example, it was close to 4%. I missed writing that down, but the range is mentioned there. So that is a lot of water. On average, there is a 500 gallons per day per bed consumption across the hospitals in California. Again, hospitals need water for their functioning. So if you see that 500 gallon per day per bed, the code required minimum is 50 gallon per day per bed. So that's 10% of what typically hospitals use on a daily basis per bed. So that's why minimum might not be the answer. That's why we are asking for water rationing plan, where things are thought through and the actual usage is calculated based on the emergency protocols. This is a new executive summary table we added to the advisory guide in the latest update. There were some water rationing plans which we were reviewing that were submitted were not clear on what was existing and what was proposed in terms of site water tanks and tanker truck arrangements. So this table helps list the overall summary in a very concise format. The table has 3 columns to account for the first 24 hours, then the next 28 to 48 hours, and the last 48 to 72 hours. The table summary asks the design professional to indicate the minimum code requirement, the current water usage, which comes through the water bill, the water rationing plan requirement for water for the 3 days is broken down again separately to make sure that if there is any distinction on the on-site storage and water replenishment part through tankers, it could be distinguished and listed within the table. Similarly, there is information on wastewater similar to the water part. And then there is also a line item for the services affected during water rationing plan. You can reference your other table that we previously showed, since the information might be difficult to fit in this table. As always, look at the footnotes, and they provide important information. So in the next 1 or 2 slides, we wanted to just show you like a hypothetical example. This is not a real facility, but kind of just give you an idea of what the process looks like. Again, let's say in this example, we took a 300-bed acute care hospital building example. First step, look at the existing water bill. Average for this facility, hypothetical facility, came out to be like 80,000 gallons per day, and the maximum is approximately 150,000 gallons per day. again, over here, since I was making the graph, I put in numbers for industrial, potable, and irrigation, which when you look at the bill, you might not have that. Again, some thoughts need to be, some things need to be worked out with your mechanical engineers to figure out what your industrial part is and things like that, to understand what your variations are. Some of it could be kind of anticipated through the difference in the water bill for summer month versus winter months. But anyways, the first step is to look at the water bill. For the new buildings, in design, extrapolating from a similar existing building is acceptable. So you can go that route. So do we need, the next question would be, do we need water rationing plan? Well, if you can put a tank size which is greater than 72-hour demand, you do not need a water rationing plan. You are already continuing operations in a normal fashion. But as a lot of facilities do not have that option because of site constraints or cost or whatever it is, if your tank size cannot be that much and it's less than 72-hour demand, then a water rationing plan is required. So for this hypothetical case, a 300-bed hospital, 50 gallon per day per bed for 72 hours, the demand would come out to be 45,000 gallons. That's minimum per code requirement. And per the exceptions in the code, you are allowed to go to a 24-hour on-site water storage capacity, as long as alternate arrangements are made and approved by us and CDPH. So the next step, you need a water rationing plan. So then having the design professional sit down with the facility and come up with the potable water usage in emergency, industrial water usage in an emergency, looking into the possibility of limiting services, stopping irrigation or stopping water to non-acute care buildings if that is possible, and providing fire watch. Some facilities have fire tanks, some don't. So just understanding what your facility has, working on issues like infection control, temperature control, all that things work together, and then come up with your water rationing plan, list all the services that are becoming functional, and putting it all together in an executive summary. So you finally come up with a number. And let's say that number is 60,000 gallons. Again, it's less than what the normal usage is. So it is under a rationing plan. So in this hypothetical example, the 60,000 gallons, 45,000 gallons are coming from potable and 15,000 is coming from industrial for the 72 hours of continued operation. So you can go ahead and put that tank there. Again, this is greater than the 45,000 minimum code requirement, or you can use the code exception to provide an on-site tank for 24 hours of continued operation, which would be 20,000 gallons, 1/3 of 60,000 gallons, and have water replenishment options available as tanker trucks or wells, whatever you choose as part of your emergency plan. One thing to make sure is all these numbers should be larger than the minimum code requirement when it comes to 50 gallons per bed per day. The next step would be to look into wastewater tank requirements. Again, for wastewater, one thing to note is that it's not going to be the 1-to-1 ratio with water. Of course, you can put the same tank size, but there is going to be less wastewater, since some portion of the water is used in industrial process of cooling or heating, and there are also other non-recoverable cases, so you can reduce that amount. So for this case, let's say we did the calculations and it came out to 45,000 gallon, and most of it, majority coming from the potable water. Again, we are recommending 24 hours holding tank, but a combination of leak-proof bags with holding tanks can also be used for first 24 hours. That is permissible. Just make sure there is sufficient time, that is taken into account, provided to install the leak-proof bags in the hookup location, and that the holding tank size is sufficient for that time while you are bringing the leak-proof bags in place to install them. For the next 24 to 72 hours time frame, combination of leak-proof bags or Cevotex can be utilized. Excuse me. Okay, so we understand this water rationing plan in an event of earthquake is probably a small portion of your overall disaster preparedness plan for hospital. Hospital functions might be affected due to pandemics, wildfires, weather events, terrorist attacks, chemical spills, and earthquakes. We just want to make sure that when the facility disaster preparedness plan is updated for the water rationing plan that we are talking about, all the stakeholders who control building operations under emergency are notified about these updates. So they are aware of the intent of this plan, and hopefully they are not still going to code dry or previous plan that the hospital had. Since this is a big investment, we want to make sure everyone who makes decisions under emergency is up to speed with these plans. So now we will talk about the submission of water rationing plan, its submission process, review process, and kind of the approval process. So when you prepare your water rationing plan, it gets submitted to us, to HCI. So when you submit it to us, we will triage it, we will review it, we will give comments and feedbacks as necessary to the design professional. After resolution of any major comments, we will route the document to CDPH for approval. If CDPH has comments, we will forward it to the DPR. So all communication is happening through us so that there is no confusion. Internally at HCI, the review is assigned to, depending on the plan, mechanical, electrical engineer, and also someone within seismic compliance unit. Again, we are not going to be reviewing or asking questions on why and what services the facility is choosing and the reasoning behind it. Most of the discussion related to that aspect is based on the comments from CDPH. So we have included it here to give you the best information for preparing the plan. Another thing that we get asked a lot is about who to contact at CDPH and who is reviewing their project. Our system currently sends the water rationing plan to a central email, and they distribute it to their applicable regions in CDPH, where the facility is located. So the region reviews it. So we are not aware of the contact person who would be reviewing your project. You are most welcome to contact CDPH directly if you would like to discuss anything with them regarding your plan, but the formal comment process will be routed through us as I previously mentioned. For new buildings, typical process, it's a H or an I project. If it is an incremental project, just please keep in mind, we have seen sometimes the water rationing plan is one of the last increments and submitted at the latter part of the design process. these tanks sometimes have huge lead time. So just keep that in mind, the timeline wise. Again, on our side, it's us and CDPH reviewing it. So we try to streamline it as much as possible, but still there is two agencies involved in reviewing. So uh, it's best to allocate enough time to make sure there is time for proper review. For existing buildings, we have mostly seen campus-wide plans being submitted, which makes more sense. And well, that's a good approach. And again, this is a building specific rating. So we will internally copy and create multiple projects for each building. But as far as you're concerned, your project is a campus-wide plan. We will review as such. It will just have more project numbers internally to keep track for each building. There is a link over there showing how to submit projects to seismic compliance unit. Again, for existing buildings, sorry, I didn't mention that before, the projects will go to our seismic compliance unit for review. Another to mention, if there is construction involved as part of your water rationing plan, if you're proposing to put water tanks or wastewater tanks, then the 2026, 2028, and 2030 deadlines will kick in, as Ali was mentioning before. If not, then you are good to get NPC 5. So now it's CDPH. CDPH has their internal evaluation tool that they use to review your water rationing plan. We have included this as a reference. Again, this is not available publicly, but CDPH is okay sharing this with everyone. So we have this in our guide as an appendix. You do not need to submit this checklist. This is just for your reference. The checklist covers items like general requirements, facility equipment, infection prevention measures, medical services, nutritional services, and pharmaceutical services. The checklist might look like it's kind of a yes or no, black and white, but it's not. There is always a case-by-case discussion. Include as much information as you can to help understand CDPH your plan in case of an emergency. CDPH also has all facility letter that they issued end of June. So that is available on the link that's shown here, and you can look at that. There is nothing different than what we already talked about. So that's that. Just looking at time. Okay. So frequently asked questions. We have a section on our website for frequently asked questions under Seismic Compliance Unit. These contain everything: SPC 2, 4D, 5, NPC 2, 4, 3, 4D, whatever. All the questions that we are asked frequently, we try to put them up there. So please go ahead and look at that. If you have any question, it's most likely been asked before, you will see the answer there. For this presentation, I'm gonna go into NPC 5 specific questions, and we have these included in our guide as well, so you can take a look at them. So one of the questions is, some of the buildings under HCI facility website have NPC SPC ratings with an S letter, such as a SPC 5S and or an NPC 4S. So what does that mean? So S is a designation reported to OSHPD. So this is kind of a self-designated number. It's not an approved rating. This as designation typically indicates that there is some missing documentation that needs to be required. So if you see this for your facility, please contact Seismic Compliance Unit, and we can explain you the further steps that are required to clear this designation. A lot of times S is relevant when it's under construction because it's still under construction, but if your project has completed construction and still shows an S designation, that should be resolved. Do hospital facility need to meet the requirements of NPC 5 now? I believe Ali talked about this, and I did too. Like for existing buildings, the milestone date for NPC 5 is January 1, 2030. Again, there are additional milestones to make sure that we meet that date, but the compliance deadline is by January 1, 2030 for new seismically separate general acute care hospitals that are greater than 4,000 square feet. It is required to be NPC compliant at the time of construction. And that's listed in CBC Chapter 16A, as shown here. Is NPC 5 a campus-wide designation like NPC 2 or a seismically separate building designation? There was probably confusion about this before because the way we talk about NPC 5 is more of a resilience of the facility. But NPC 5 is a building specific designation, with facility-wide compliance expected by 2030. New seismically separated building constructed to the 2010 code or later are required to be NPC 5 compliant at the time of occupancy, as I previously mentioned. Is the hospital facility required to have storage tanks for 72 hours of water and sewage? Are the tanks required are too big, and our site does not have the room for placement of such tanks? So again, as we had previously touched on in the presentation, there are exceptions. Code requires you to support 72 hours of emergency operation, but there are exceptions that do allow for smaller tanks when alternate arrangements are made. Does the NPC 5 requirement of 72 hours of water refer to potable water only? Is industrial water or processed water to operate hospital facilities included in the storage requirement? Again, this might be a repeat since we talked about this in length in the presentation, but the NPC 5 requirements refers to both potable as well as industrial water. There's the continuation of the response over there in this slide. For seismically separate buildings, there is a minimum requirement in the code of 150 gallons per bed for the 72 hours. There are exceptions, and when there are no licensed beds, as we talked about for central utility plant, then it must provide water for 72 hours of emergency operation for itself or any other new buildings, but not necessarily for the existing buildings on campus, because those need to be complied by 2030. Of course, you can do it sooner, but the deadline is 2030. The response is still continuing in this slide. I just wanted to make sure the text was legible, so the response is kind of copied in multiple slides here. But all this is saying is please work on your water rationing plan. That will dictate how much water you need, and that water rationing plan needs to be accepted by CDPH and HCI. So again, the response is continuing here. We do reference the CDC guide that's available as well. So we'll move on to the next question. Does the facility have to comply with section 615.4.2 of the 2022 California Plumbing Code even when using the exception in section 615.4.1? This question does get asked a lot, so so the response is yes. And the section 615.4.2 of 2022 California Plumbing Code requires the emergency supply of water be provided with sufficient pressure using gravity pressure tanks or booster pumps. If booster pumps are provided, they are required to be connected to the emergency power supply system. The section 615.4.2 all applies when the exception of 615.4.1 of California Plumbing Code is used to ensure that the emergency supply of water is delivered to the endpoint usage at sufficient pressure from the storage tank. The ability to dispense water to portable containers from storage tank required in the exception of section 615.4.1 of California Plumbing Code is to be considered a measure of last resort. So yeah, this was a frequently asked question. So again, please look at it. I just read it verbatim over there. If you have any questions further, feel free to reach out to us. Per section 7 to, so this is the next question. Per section 7 to 7 of 2022 CPC, can the facility store sewage and liquid waste in a 5,000 gallon tank? Does the tank need to be connected to sewage line? Again, I think this was covered, but yes, the holding tanks are required. However, there is no minimum size for holding tank provided in section 7 to 7. The capacity shall be based on the water conservation plan. Again, we are saying we are recommending a minimum size of 24 hours for holding tank. Again, the purpose of holding tank is to prevent 72 hours of continued operation if external sewer connector is damaged. And we do not have any requirements on connection of the holding tank to the existing sewer line. However, if connections are provided, make sure that they're made with sufficient walls to isolate the external sewage lines. Can we use bladder tanks to store sewage and wastewater in parking lot? Yes, the exception in Chapter 7, Section 7 to 7 of California Plumbing Code permits that. Again, this is pretty much a repeat of what we had talked about in our presentation. Just make sure that wherever you use in parking lot or so forth, these locations comply with the requirements of lockable screen enclosures and things like that. This frequently asked question is about buildings to be removed from general acute care, and I believe last few slides of what Ali was presenting covered this, but again, the requirements are similar to a building that is going to comply. There are the timelines in a sense where if you're going to be removing it, we need a letter signed saying that these are going to be removed by the 2024 timeline, and by 2026 they need to submit a construction project, and if there is no construction project required for the removal of acute care services, then this step could be skipped. And the last deadline of 2028 leading to the 2030 deadline is removing acute care services construction project shall obtain building permit by 2028, and once the closure of these projects in compliance and no construction rock project shall be submitted to the office for applying for removal of acute care services, indicating whose jurisdiction the building will be in, the local authority or OSHPD. And once the project is closed in compliance, submit a project by January 1, 2030 to the seismic compliance unit to remove the building from the acute care building inventory. I believe those were all the most frequently asked questions. I'm guessing we might have an addition of frequently asked questions after this, but I will hand it over back to you, Ali or Kelly, if there are anything.
Thanks, Kamal. We have received several questions, so we try to answer as many as we can when Kamal is presenting. So since we are running out of time, we will try to answer those with an email. So let me turn to Kelly to finish the presentation. Thanks again. Kelly? We cannot hear you. Kelly's having some audio difficulty, but what I can say is, again, please take a look at the AIA slide in the beginning. The handouts are in the dashboard, and also the recording of the webinar will be available in few weeks. So with that, Kamal, we are still seeing your screen. So with that, thank you again, everybody, for joining. And if you have further questions, please use this email and let us know. Thanks.